Hey guys, welcome back to Predictapalooza. I thought I would start out this installment by reviewing where things currently stand. So, the last installment, Brian came and picked up his lovely brown princess Predicta. While doing so, he dropped off a debutante for me to fix. Well, actually, he dropped it off so we could swap out the screen cover, but he left it with me with the thoughts that we could restore it. Well, eventually dig up a screen cover from somewhere. So we have this debutante, perhaps. I'll have to order up some parts for that. I don't have enough on hand. There's mine with the UHF option, which is restored and working, but needs a lot of cosmetic work. There's Tom's brown princess, which is nearly done. There is Siggy's beige princess, which I hope to finish in this installment. And then there are some sets that we haven't gotten to yet. Well, there's Tom's debutante, which I believe I did restuff the main board, but that still needs some work. There is a Continental chassis, which needs a ton of work. I got to talk to the owner about exactly what we want to do with this. We'll take a closer look at it, but the issues are it's missing stuff. Yeah, it's a bit of a mess. And then there's this set, which is another debutante, belongs to Chase. It was dropped off. I don't think I've shown you guys this one yet. It's black. It's in very nice condition. And he, I guess, had thought he would work on it and then decided not to, but he ordered up parts for it. So he got the same replica cup plates that I used on the other sets and a bunch of other parts. So that's one reason I wanted to take this one on, is that he supplied me with all the parts that I should need to get it going. So I figure I'll do two or all three debutantes at the same time, because they're a little bit different than the princesses, so I want to be able to compare and contrast while I'm doing all of them. So to recap, in this installment, we want to get Siggy's set all buttoned up. It's working, it's been restored. I just need some cosmetic work and reassembly, I do believe. And we'll get Tom's princess done too, I hope. Then we can move on to all the debutantes. I forgot, there is actually a bit of work left to do on Siggy's set because it had been poorly previously restored and some of the original parts are missing or mangled, damaged. We need a tube shield, we need a width control, and we need a new linearity control. So luckily I have some parts chassis. I can get some of what I need from them. The salvage operation is underway. I just removed the width control by carefully untwisting those tabs a little bit. Next up, I want to try to remove this assembly. That is the collapsing tube shield that goes over the 6CG7 horizontal oscillator tube. If you recall, somebody had replaced the socket on this board and used one that had no shield whatsoever. The final piece of the puzzle is that linearity control is already gone from this set. I have a plan. Talk about that in a bit, and then it's a matter of tracking down the parts I need. I ordered some online, but I might have something already here that I can use. I need to replace these in a bunch of sets, so got to come up with something that's replicatable and doesn't disrupt things too much. With the help of a propane torch applied very conservatively, I was able to pop this out. Now I'm left with a few options. I could install this as is into the board. Potentially the problem is, this is the type of socket that has the thin metal fingers that, when stressed enough, can start cracking. Will start cracking. Which I'm sure is why they replaced the original socket on this board. What I don't understand is why didn't they transfer the shield when they replaced the socket? Because it looks like that socket is the same as this. It's just a different color material, as is this. So another option is for me to take this, which is new old stock, but with metal that's twice as thick. Otherwise it is identical. And I can transfer the shield onto this and then install it on that. I mean, even the little tabs there are places for the metal tabs on the shield to go. So it can definitely be retrofitted onto this. Or I can try retrofitting this shield onto that socket, which I might not be able to do with it in place installed because I need to bend those metal tabs under that socket. I'm not crazy about removing that socket, however, because the board's already been through enough stress with the crude soldering job that was done before. But one good thing is, even with the board installed on the chassis as in here, you can get at that socket. And you can get at all the pins without having to worry about this metal being in the way. So that's one thing working on our side. Well, while I ponder that, it is rusty, so I'm going to throw this into an evapor-rust bath. So while I ponder how to get this onto that chassis, I'm going to start working on the solution for the linearity control. So this is a simplified diagram of that vertical output circuit. There's a 6DR7. It's a dual triode. There's a sawtooth coming into the grid, and that powers the vertical output transformer, which goes to the vertical deflection coils in the yoke. To bias it, get it to the proper operating point, they put a variable resistor in the cathode circuit going to ground. If this goes open, the tube stops functioning, you get zero vertical deflection, you get a line burned into the screen. So I wanted a little bit more detail about the actual voltage and current and so on. So I had two options. One would be to play around with my SAT and measure some parameters, but luckily the SAM's photo effect helps me out a little bit because they put some operating conditions on the schematic. So here's that same circuit. Here's your basic triode. The other half of the tube, the other triode, is the vertical oscillator or multivibrator that generates a signal that looks something like that, sort of a sawtooth. That modulates the grid on this tube, and it goes through the vertical output transformer. So the way a basic triode works is you got a plate, that's the positive, you get a grid that has a negative DC bias on it to set the operating point, and then you modulate that. Then it's got the cathode, which is where the electrons come from. So the electrons start out down here at ground, and go up through this control, go to the cathode where it gets heated by the heater, and the electrons get boiled off, they get modulated by the grid and attracted to the plate, and go through this coil and back to the B+. Alright, so that's all cool, except when this fails, and then you kill the flow of electrons, and the magnetic field collapses, and you get no deflection. Well, they gave us some good info here. So, they say if you've got 15 volts on the cathode, you've got 30 milliamps flowing through it. And also on the resistance chart, they said that they measured 450 ohms on the control setting that they used. So that's what I did in this simplified diagram here. And yeah, the math works out pretty much. 15 volts, 30 milliamps is roughly 450 ohms. That also translates into 1/2 of a watt. So that's one of the things I was wondering about. They used a wire-wound control, which are kind of expensive and a little hard to come by. And I was wondering how much wattage does this thing really typically be kicking out? We came up with this with 1/2 a watt. So probably a 1 watt control would be sufficient. And yeah, depending on where you set this control, you get more or less current flowing, but unless you're, if you go to the extreme, I think your vertical deflection is going to be very distorted, so you probably wouldn't be in that area. Alright, so anyways, so we got some rough parameters here. So what can we do to make this a more reliable circuit? Well, my thought was, instead of having a single control, and by the way, they put a stop in here, a mechanical stop, so you can't adjust this so it's a dead short, because then you would be biasing the tube way too strongly and it would red plate. You'd be exceeding the safe operating zone of the tube, so it's got to stop at 180. So you can essentially think of this as a fixed 180 ohm resistor in series with a variable 1320 ohm resistor. Alright, so my thought was, let's introduce so that if the variable control fails, we still have a path for the current to flow. So something like this, and we put the variable control over like that, and these two are fixed resistors. So you can tweak this one to adjust this, and this would be like the 180. So even if this is a dead short, you've got at least 180 in there. But also if this fails, you've always got this fixed resistance in here. The question is, what values should we use? I'd also like to set this so that we can use a lower wattage control here, which are less expensive and easier to get, like a carbon control rather than a wire wound control. So I'm going to play around with some math a little bit, and also I want to end up with a practical value for this, like a 1K resistor, a 5K resistor, you know, something that's commonly commercially available. Well, I did a little noodling around, and here's a couple of potential designs I came up with. This with a 2.5K potentiometer, that in parallel with 2.7K, and a 180 ohm will give you an equivalent range to the original, and this one uses a 5K in parallel with a 1.8K and again a 180. Either one of these should work alright with a 1/2 watt potentiometer. What it really comes down to is what do I have on hand, because I need to replace these in at least 3 sets. So I'd kind of like to do the same thing in all 3. Alright, we have a design concept. Now how can we make it a reality to try it out? Well, I played around with the circuit, designed a little bit. It seemed like for worst case scenario, the pot could have a little bit more than a watt being dissipated. So I figured for some overhead, we better go with a 2 watt potentiometer. Or I guess more accurate would be a rheostat, because I think when there's only 2 resistance elements being used, it's a rheostat, whereas potentiometer is variable potential, meaning you have all 3 terminals being used. Let's not argue semantics right now. We want to find a 2 watt potentiometer rheostat that is around 2.5 to 5 kiloohms. Now there happens to be a very, very nice type of control that's been made for many years, which is the Allen Bradley Type J, which just so happens to be 2 watts. And in particular, they make a variation of it that has a short little stubby shaft with a flat slot in it, and then you can have a locking nut on it. It's meant for calibration, like on an oscilloscope or RF generator or something. I think that would make a fine type of control to use in this situation. It's a little bit bigger than the original. We would have to enlarge the hole a little bit, but not too much. It should fit. It is discrete, and we don't have a long shaft sticking out. It's not like a control like this would be kind of obnoxious, and the back wouldn't fit on the set without having a hole cut into it and such. And these are military grade. They are sealed from the environment. They have this conformal coating on them. They're good stuff. Allen Bradley, I think, stopped making them a while ago, but I believe Clarostat may have kept making them until fairly recently, because I found them online at Allied Electronics, although they were listed as being obsolete or discontinued. But at least they were in the catalog, and they were listed, I think they were $10 new back when they were still available. I did find some on eBay. I think they were new old stock. I think they were $8 or $9 each with free shipping, so I ordered all 4 that they had on hand because I need to replace this in almost every one of these sets. It just so happens that the first 2 that I completed had really nice original controls. I think all the other sets I have, they're missing, damaged, they have ugly replacements, so we need a repeatable solution. Alright, now I already started poking around in this and I found a 2.5K control, but it has a full-length shaft. But at least we could experiment with this one. Meanwhile, I'm going to keep looking for these shorter ones to see if I can find one that's suitable. The drag with these Type J's is a lot of them do not have the values on them. They have part numbers or whatnot because they were made for OEMs or the military. So I'm going to have to get out my own meter and just check and start checking all of these. I suspect I won't be finding a lot. That's why I ordered some before I even bothered checking, because these are old. These are from the 40s, the 50s, the 60s, the tube era, where typically you would have controls in the mega ohm range, not the kilo ohm range. And I've already seen some of these are 1 meg, 5 meg, the ones that have printing on them. So, anyway, so I will dig through these and see what we can come up with. I'm still searching, but I stumbled across one that was busted open, so I thought you might see what is going on inside. It's a little hard to see, but there is a thick black carbon track running around the outside, and there's a fairly robust element that rubs against it, which looks like some kind of composite material, maybe carbon or something. So that's the part that makes contact with the carbon track as it rotates around. I dug up a few candidate controls with values ranging from 2.5K to 5K. I figured let's start out with this guy, which is 2.5K because it has a long shaft, so I can easily rotate it and see what the response is like on the screen. Now my other concern is, well, will it fit? Let's look on this parts chassis for a moment. That's where the original linearity control was. It was riveted at these 2 points and the shaft came out there. So I would like to enlarge that hole and mount this on the other side. I'll have a slotted shaft looking very much like the width control does. I wasn't sure it would fit. So I'll have to drill out that hole larger, and it'll sit on the other side somewhere's right about there. And it turns out that, yeah, it will fit. There's just enough clearance between it and that CRT socket up above, so I think we're all right in that regard. Alright, so I'm going to put the parts chassis aside and pull out this chassis, and let's get things rigged up and start experimenting. Well, I've run into a bit of an issue with finalizing Siggy's Princess. Let's talk about the good first. I removed the tuner. It's been cleaned up. Have some good tubes in there. I've wired it up. It works fine. I also replaced the 47 bulb with an LED equivalent. And notice this tube is a little bit different than the last one we looked at. This is how most of them I've seen, where it's just a cardboard tube that's open on the end. But if you recall that last one, the end was folded over, so there was just a little smaller diameter circle open at the end, which I think maybe chokes out the light a little bit too much. So, yeah, anyways, I thought that was curious. The fine-tuning knob was cracked. In fact, I have a feeling that they're all cracked if I look close at them, but same repair on all of them. Just feed in a little bit of the acrylic Type 4 cement, a little bit of clamping, and fixes them right up. And I replaced the width control. It's mounted in firmly, wired it up, powered the setup, works fine. Until this happened. One problem with this set is it was around a heavy smoker's environment, maybe a bit of high humidity at some point. I've been able to clean up the tuner and the IF shield and the high voltage box, the whole CRT housing very nicely. But the one thing that really has been impacted by it is this wiring. And you compare it to Brian's set that I recently put all together, and well, you even see where this tape was. This is nicotine stained. I tried cleaning it with a couple things briefly, like alcohol. Didn't really do much. So you gotta just live with it. But it's made some of the wires a bit more brittle too. So what happened was the one wire that's separate from the rest that feeds to the video signal broke. The insulation was already a little dubious from getting flexed. It was a little compromised in areas, and it just completely broke off here. So we have to replace it. What are we going to replace it with? Well, a lot of the wiring, like this yellow, this white that I've been using on these sets, got spools of it up here. This is PVC insulated wire, good for 600 volts, which is fantastic, but it's solid core. There's just one single copper wire in there. This stuff needs a little bit of flexibility because this head unit gets rotated around. You need a little bit of give on these wires. So we need stranded. I don't have any stranded that's rated for 600 volts with PVC insulation. What I do have is some of the silicone insulated stuff, which will work fine. That's what I'm going to try using, or will use. But it's super flexy. If you recall on my Siesta set, the one that was just disgustingly nasty that I did a little over 2 years ago, I ended up completely rewiring the yoke, and I used this stuff. That's why I ordered up a few spools of it. It's great. It's super flexible. It does have a good voltage rating. It is stranded, so it'll certainly stand up to this twisting around. But it's a little squirrely because it's very flexible. But that's what I'll do. I hope I can do it without having to take the CRT completely apart. This wire should feed up through here directly to the plug that goes to the base of the CRT. I'm also hoping that I can attach the new wire directly to the plug. If not, I'll cut it back, just leave a little stub of the old wire and splice it in, put heat shrink tubing over it, and then try to feed this down through here. Now, because it's so flexible, I think that feeding it might be a little tricky, so I might fish a stiffer wire up through here, attach it to the end of this, and then fish it down through, like when you're trying to fish house wires through conduit or whatnot. Once we get that done, we can finally get back to our linearity control experiments, and once that is done, we can finally start buttoning this set up. And one final thing, while I have it completely apart, I'll clean this up a bit, get this goo out from around where the CRT is, and do a basic cleaning on the outside of the cabinet. Clean up some of this gunk on the inside of the bottom too. Overall, the original paint is in pretty good condition, as is perforated grill and the trim and whatnot. I'll pop this off and give it a bit of cleaning too. It's got a bit of a yellow haze, again I presume from cigarette smoke. I'm doing a little cleaning on the cabinet right now, and wow, it's pretty impressive how much nicotine staining has built up on this. Check this out. Yeah, wow. Don't smoke, kids. That actually cleaned up quite nicely underneath all that cigarette sludge as usual. It did a pretty good job of preserving things. Certainly the ivory paint on this looks a heck of a lot better than my rust bucket next to it. I got a suggestion. about putting this in a dishwasher or some such to wash it down. I would if I could. The problem is behind that front metal mesh, there is this masonite kind of material. And there are a lot of screws press fit into it. Getting that out is not easy. You need to remove all these nuts, which are these cheapo press metal nuts. It's tough to get a good grip on them, and once you do get this out, over time these tend to warp a little bit, and getting this all back together can be a challenge, so I figured it was best just to clean it up with it assembled. And I'm pleased with how nicely it turned out. So let's turn our attention back to wrapping up the chassis, fixing the broken wire, and rebuilding the broken antenna. Just about done with the repair. I examined the wire and determined that the insulation was actually fine for quite a bit of its length, so I cut it off fairly far back. That means that when I reattach this and thread the wires down through the neck, you won't see the splice. The splice, I mean, if you took the back cover off, you wouldn't see the splice. The splice will be down here. I soldered the two ends together and did a double layer of heat shrink tubing. Now I just simply need to thread this down through the neck, reattach the base, and cut it to length. I left it extra long because I wasn't sure quite how long it needed to be. I'll put that connector on the end, and we can resume where we left off with the chassis. Since I have a 2.5K pot with a long shaft handy, we're going to try that design first. I also dug up some used ones, and I ordered up some that are used off of eBay, but they're newer than the other ones I have. Why am I spending so much time on this? Well, if you've been watching this series, you may have noticed that I haven't really had any issues with these sets. In fact, the only issue that is attributable to the original design or any component flaws, it's this linearity control. Only other issues I've encountered so far really are sloppy old repairs on one set that had a burn trace that I don't know what happened with that. So let us proceed. So we're going to use a fixed 180 ohm resistor, fixed 2.7K resistor, and then the variable 2.5K. Now the original resistor is spec'd out at 2 watts. I'm using 560 here, and it just barely gets warm. So I'm using, again, a 2 watt variable pot. For these other resistors, I'll use 2 watts just to over-engineer it, but I don't think it's really dissipating that much power. Figure if about half's going to go through here and half's going to go through here, and then it's going to be somewhat divided into this as well. We're going to be dissipating the heat over 3 parts instead of 1 part, so if that's barely getting warm, these are really not going to get very warm. Here is my test control. The center wiper and one leg are shorted together. There's a 2.7K resistor in parallel with that shorted leg and center wiper and the other leg. Then there's a 180 ohm resistor leading off to ground, and the other side goes to the vertical linearity stake on the board. So let us see what effect this has. We want to check 2 things. One, does it work? Can we vary the vertical linearity with sufficient range? And 2, we're going to simulate the control failing. I'm going to do that by clipping one of the leads going to the control. Well, I can see it's had quite a bit of an effect already because we have less height and the linearity is pretty miserable. So let's see, I'm trying to get the best camera angle I can for you guys. It's a little awkward with the picture tube on the bench such as it is, but there we go. Alright, now I'm going to vary the control. I think we have sufficient range. So now instead of being squished at the top, it's really stretched out. It's squished at the bottom. And as I rotate it, it starts getting swished at the top and stretched out at the bottom. Now, this is not the be-all end-all. There's also a height control and a hold control. So it's not at all unusual to get good linearity, but you lose some height when you adjust the height control and you go back and forth between the two. Unless I lose hold here, well, if I go over and tweak the vertical hold, I can get it back. I think we have sufficient range, because I can get it from being just a complete mess to looking pretty good, and then a complete mess again. Or a better way of putting it maybe is I go from it being stretched out to good linearity to it being squished. Now, I have not checked all the tubes in this set, in particular the vertical output tube, which will also have an effect. There's a bunch of stuff at play here, so you do the best you can. Alright, so I am going to cut one of the leads going to the pot, leaving the other two resistors in circuit. We're going to simulate a failed control and see what happens. So here we go. 3, 2, 1, cut. That's what I want to see. Yeah, it's miserable looking, but we did not lose deflection. This is not going to burn the CRT. Excellent. And if we reestablish contact, very cool. And here is the final setup. So I enlarged the opening here with a drill bit, an electric drill. The only little trick to it is this bracket that the CRT plugs into also runs right up against that hole. So it's a little awkward with that nut on there. It's not fully supported on all sides, but it's not going anywhere. It's on there solidly. So it's just enough room. It worked out great. And I mounted the two resistors here. Now the one going to ground, I just cranked up my soldering iron and soldered it right to the chassis, and then ran a wire over the linearity control. So that is that. I want to go over the last few final details just to give you some idea of the little things that can easily get overlooked. For example, there's this horizontal ringing coil down here, and sometimes the tape wrapped around it can start to unravel. So I got some Captain tape and wrap that around there to secure it. I also replaced the cable clamp that secures the two wiring harnesses for the control clusters. I checked and cleaned all the tubes. One last thing I need to do is secure this brass ring. Sometimes these are missing, but they should be pressed up against the fine-tuning knob, like so. I think it works in conjunction with that light to illuminate the fine-tuning knob. Originally, it looks like these were pressed into the plastic while it was soft, or maybe they were glued in place, I'm not sure. I will try the plastic solvent that I've been using to repair these knobs. If that doesn't work, maybe some hot glue, or maybe I'll melt the plastic a little bit. Sometimes these are missing. You can imagine once they come loose, if this knob is pulled off, they get lost. But this one still has it, so we're going to get that reattached properly. This did have the bracket on the back. It's missing on most of these sets. This still has some tobacco residue that needs to be cleaned off. I'll take care of that. That is the very last thing that will get reinstalled, because it goes on the chassis after it's installed in the cabinet. And then we have the antenna, replacement antenna to trim down. That stuff can wait. Let's start putting all this stuff back in the cabinet, and then we can adjust all the controls to get the picture looking great, and then we will be done with this set finally. Before I button this set all back up, I thought it would be a good idea to do a final test, this time with a real video source rather than a test pattern generator. When I did, I found that the image and sound quality were not as good as the previous sets I had restored. Also noted that the local distance switch wasn't doing anything. That affects the AGC circuitry, which goes to the IF board and the tuner and controls the gain on those circuits. Well, I double checked the wiring and the switch action, and I checked the wiring to the IF circuitry. That's all fine. Also noticed the contrast control wasn't having as much effect as I thought it should have. Double check that wiring. That's all fine. So I went back to the main board and checked something that I should have checked sooner on. I also should have checked that that local distance switch was doing its thing. You may have noticed that generally when I redo these main boards, there are two resistors I haven't been changing out. This guy and this guy. They are in the AGC circuitry. One of them goes directly to that local distance switch. Why haven't I been changing them out? Well, it's an oddball value, 12 mega ohms, although I do have some replacements. They're not quite the type I'd prefer, but it's the only type I could get. And when I've checked these in the past, they've always been fine. But in the past, I've also remembered to check the local distance switch before I put the set back together. So, a few issues. One, I should have checked them. And by the way, you can't check them when they're in circuit because you're going to get about 1.5 mega ohms because they're connected up to other stuff. You have to free up one leg and isolate it. And when I do that, on this one particular 12 meg that goes directly to that switch, I get nothing. It's infinite. It's open. It's completely open. That's unusual. But, you know, when something doesn't work, check the most obvious thing first, which was the switch. Okay, that was okay. Then the next thing to check is, what does the switch attach to? Well, one side of it goes directly to that resistor. So even though they've always tested fine in the past, it's the most obvious next thing to check. And what do you know, it's bad. This other 12 meg I also can't check in circuit because of other components. So I have to clip that as well. Now, I am pretty sure I can replace this from the top side without having to pull the board out. Either through some cutouts through the metal underneath the board, or if I have to, I'll go through the top. Worst case scenario, I get this clip lead out of the way. It goes between these two stakes. So if I had to, I could just wrap the resistor legs around these two stakes. One way or the other, it'll get replaced. So, lesson learned, always check everything, even if it's something that rarely fails, always been fine in the past. Check it. Also check all the functionality before you put something back together. You'll save yourself a lot of headaches. I replaced both 12 meg resistors and put the set back together temporarily. In other words, I just hooked everything back up. I didn't put all the screws back in because I want to make sure it's working right first. You know, one nice thing you can do with these Predictas is, because you can swivel the screen, you can look at it full on while accessing the back of the set, because you can rotate it over 90 degrees from the front. Alright, so this is the issue I was having before, where it's pretty crummy looking, right? Well, let's try that local distance switch. That's what I was hoping to see, that before that switch didn't do anything, so that boosted the gain. That's what I want to see. Excellent. Let's check the contrast control. Some minimum contrast, maximum. Excellent. Cool. Now linearity is pretty bad. You can see it's stretched at the top. So now I'll get the test pattern generator back on it and make all the final adjustments. I think we are finally close to getting another Predicta done. The set's been playing well for about 15 minutes, but the audio is not as good as it could be. It's got a bit of a buzz to it. So what can we do about it? Well, this coil right here, we're going to tweak it a bit. Just going to do it by ear. Better. We can do a little better than that. Much better. I don't know if that's the official procedure for it. I know on the 21-inch sets there's literally a buzz control, but that uses a little bit different FM demodulation technique. But that definitely did the trick.
Diabetes better, and I've lowered my A1C from 8.2 to 6.7.
So I'll take it.
Mystery out of managing your diabetes.
I'm going to let the sets run for a bit longer. I'm going to cycle the power off and repeat and let it run for 15 minutes each time or so. After maybe an hour total playtime, I'll be satisfied that it is good to go. Time for the final adjustments. I just took the back of the CRT cover off. There are two things you can do from the back of the CRT here. You can center the picture and you can tweak the horizontal linearity. There are two types of yokes they use. This is the easier type. The other type has 3 circular magnets that you can rotate in their little housings. Kind of looks like 2 more of those. This type uses concentric rings around the neck of the CRT with tabs on them. You can rotate these. These are steel or metal rings that are slightly magnetized. When you rotate them, it deflects the electron beam ever so slightly, which will move the picture up, down, left, right. They do affect each other. It's obvious once you have the set running as you move these, the effect that they have. Don't worry, there's no high voltage, dangerous voltages present in this area. The high voltage lead goes up. That's way over here. You're not going to get shocked doing this. That I generally don't mess with, because generally they don't need it. But if you look close, that's a hexagonal opening in the middle. You can put an Allen wrench in there and you can rotate that magnet inside of its little clamp there. That has the effect of somewhat altering the horizontal scan by, I guess it gives it a little bit of an assist, you could say, when it's deflecting the electron beam from left to right. The idea being if it strengthens the field in conjunction with the yoke, it'll move the electron beam faster, so it'll compress the test pattern together more. We'll be using a grid, so it'll have the effect of on the side where you're making the magnetic field stronger, it will move the electron beam faster, so the squares will become compressed, and on the other opposite side they'll get stretched apart. From what I recall, last time I had a grid on this picture tube, that looked pretty good. The main issue was centering. It's definitely off to one side. So one thing I want to do before I really start making adjustments is figure out where is the center of the screen. So I'm going to get a tape measure, or I'll just go diagonally, and I want to figure out where the center is. And then I want to get a circular test pattern that has a cross in the middle, and I want to get that centered. Then we'll get the grid up there and we'll worry about the linearity. And as we make adjustments, they're all going to affect each other. Adjusting the vertical linearity is going to throw the centering off. If I tweak the horizontal linearity, it's going to throw the centering off. Adjusting the centering will probably affect the linearity. So we're going to be going back and forth and back and forth. Alright, here's our starting point now without me having to measure anything or find the center. It's obviously off to the right, because we should have a box with a circle inside of it, so we don't even see the right side of the box. So I am going to reach around behind and get to those tabs and move them. So when I move this one, it's moving the image up and down. If I can find the other one, there we go, left and right. So, and notice it's starting to move it down a little bit too. That's what I mean about them interacting. So now I'm going to compensate and go up a little bit. Trying to get to the left a little bit more. Now there's only so much these can do. To make things more fun, if I touch the horizontal hold control, hey, that moves it too. But you don't want to really center it with the horizontal hold, because notice at the top it's starting to wiggle because things are too far off, and if I go the other way it starts to angle a little bit. Because what this is doing, this is changing the frequency of the local horizontal oscillator a bit, and the more I get it out of whack, the harder it has time to synchronize the incoming signal to it. So we want to get that so it's fairly stable. Alright, so when we have this up, let's tweak the height linearity a little bit. We also have a width control, so we got a whole bunch of stuff we can mess with. And here's a final wrinkle that makes this even more fun. These sets have no voltage regulation. I can get this looking absolute perfect, perfectly centered, perfect linearity, awesome. The owner takes it home and things are off. There's a gap at the top of the picture, or at the right, or it's the station ID logo is off the screen. Because his line voltage may be 5 volts higher or lower than mine here, and as the line voltage varies, the image grows and shrinks. So don't knock yourself too much. What a lot of collectors, restorers do is they overcompensate and stretch it so it's going off the screen maybe half an inch on all sides. So if the voltage drops a bit or increases a bit, you're always filling the whole screen. It's, I guess, more annoying to have a bit of a gap than to lose part of the image because it's off screen. And there's usually not too much of vital importance going on here, unless you're watching sports. And it can be a little annoying when the score is a little cropped off. Okay, so adjustments on the back, those you can just do with your hand. To adjust the other stuff, we're going to need a little bit of a screwdriver, like this. So we've got our new linearity control we installed. We have the existing height control. So I'm going to drop the height a little bit because it looks like it's a little too tall. Maybe that circle should be a perfect circle. And now notice we're at the bottom, it's kind of cut off there. The linearity's off a little bit. I'm going to switch to the square pattern. Yeah, it's squished at the bottom and stretched a little bit at the top, so now we're going to tweak our linearity a little bit. By the way, if you swap out your vertical output tube, you're probably going to need to adjust this. You can also see it's wavering at the top, so I want to get that horizontal hold better. There's also a coarse horizontal hold on the back, as well as there's a ringing coil inside. All of them need to be tweaked a little bit. I think I may need to tweak that ringing coil a little bit. Oops, that was a vertical hold. I meant to tweak horizontal hold. So I can't quite completely eliminate that little wavering up there. Anyways, let's get back to the linearity. So it's still a little squished at the bottom. So I need to do that, and then I go back to the height. Like I said, all these things interact. Now this is a little tricky because it's kind of stretched in the middle and it's squished both at the top and the bottom. If you get into this situation, you're basically going to have to either live with it or try swapping the vertical output tube. I know something else too. The horizontal, I guess we will play around with that linearity control because it's stretched on the left and squished on the right. So I need to find a tool. Now the only tools I think I have that would fit that hex opening are metal. I'm not quite sure what effect that's going to have on it, but I guess we're about to find out. Now let's try tweaking the horizontal linearity. I found an Allen wrench that's about the right size. It's still not the easiest thing to turn. Okay, well that's going the wrong way. Okay. And it's starting to go back. Yeah, that's as good as it's going to get. Normally they would say adjust the drive control, but this set doesn't have a drive control, so one thing we could do is try swapping out the horizontal output tube. There's also a width control. I'm going to try tweaking that a bit now. Yeah, that's what tends to happen when you adjust the width control. I think when it hits dead spots, the output collapses, which can be a little disconcerting if you haven't seen it before. So that is changing the overall width, but it is having no effect on linearity. We could also try swapping out the 6CG7 that drives the horizontal output, or we just live with it. It's never going to get perfect. I went through and I swapped out the horizontal output tube, horizontal oscillator, vertical output tube, damper tube. None of it made much difference. Vertical output tube, I think, was the only one that really had any noticeable impact, and it was a slight improvement. So I'm back to the drawing board and adjusted all the same stuff I did before. I made sure that that horizontal linearity control was maxed out to stretch it as far to the right as possible, which helped a little bit more. Be careful. Even though this Allen wrench is exactly the right size, that adjustment is, I don't know if it's Alnico or what, but it's brittle. It's like a ferrite core. I did chip it a little bit, so use caution, and I don't recommend adjusting it at all unless you really think it needs it. So I went back and adjusted the width and height and the linearity again and all that, and it seemed like adjusting the width had the biggest impact, along with recentering the picture. I'm tweaking that width again a little bit. So notice when you change the width, it also affects the height. So actually, if you can consider the center of the screen to be the sweet spot. So right there we've got pretty good squares, but I screwed things up with my linearity and height a little bit. So let's kind of compensate for that. No, it's not perfect. It kind of curves a little bit here. It's all the corners are a little bit distorted, but the center is pretty good. Overall, the linearity is pretty good. I think overall, that's a good compromise. If the only thing I could do further than this, I think, would be to add some external magnets. That's been suggested before. I've never tried it. I've never heard of anybody trying it, but I can imagine if you had some small, relatively weak, I don't think you need like rare earth magnets. That might be way overkill, and you might actually magnetize part of the frame that secures the CRT. So we'll glue them maybe on the inside of the plastic cover or something, but I think that's getting a little bit too obsessive. Trust me, if it looks pretty good here, it's going to look really good with actual broadcast material. So let's try that next.
While staying in the best shape of
there we go. Yeah, it's a commercial, but actually generally commercials can be pretty good for testing because you get text and you get stuff in the corners.
I can still get a great workout without having to kill my knees and kill my body.
Alright, cool. I think we can call this done. I am going to put the back on, secure everything, and then we'll take one last look at the set.
It's all at tryfreestep.com.
In early 1951, truth feelers materialized at the first meeting in the red-held city of Kaesong. Chesty Puller let it be known that he was not very happy with the U.S. conduct of the war.
Let's take a look at the back. We got a few things going on here I don't think I've talked about before. Here's our vertical brace, which some sets have, some don't. This set was missing the power cord. I dug through my stash of Salvage power cords and found one that fit through the original opening and hooks into those pins. There should be a metal piece around here that kind of locks it in place. I don't have it, but it should be fine even so, which leaves the antenna input. So the original setup is it has screw terminals in the center, and then tubular connectors at either end. One side goes into the tuner, so that's this twin lead here. The other side would be for the internal antenna. If you wanted to use the internal antenna, you would take the twin lead from that, and normally it would have some type of tubular connector on the other end, the male end, that would fit into these. Again, this is a salvaged antenna, so I don't have that connector on the end, but we're not going to be using it anyway, so I'm just going to leave it disconnected. But the twin lead coming out of the tuner, the original connectors were gone off that too, which is a real common issue. So I had to come up with something that would fit into these. Well, after hunting around a bit, I remembered that when I went through a recent estate, I went through some junk boxes, and I called that, I think, hidden treasures. Well, one of the hidden treasures I found were these gold pins, and I wasn't sure what they came from or what they're for, but you know what? The round end fits perfectly into these guys. So I stripped the end of the twin lead, wrapped it around the rectangular end, put heat shrink tubing over it, and it's a perfect solution. Plus it's gold plated, which is nice. If you need to do such a repair, one thing that can work is if you have a dead octal tube, bust the pins off, and they will fit into these connectors. Here's a closer look at one of those antenna terminals. This fell off of one of the backs from another set. So there's a screw terminal, and then there's the tubular, I guess the female part at either end. It's probably a custom part for these sets. It'd be cool to find a little stash of these, because I've got some that are damaged or missing. Anyways, so here's how this pin fits in, like so. So often these have been broken and mangled and falling apart. I think because whenever you take the back off to service the set, you would normally pop these out. And after doing that a few times, the wires fray and break and fall apart. So often I find sets where the twin lead is just hanging out the back and the ends have been stripped off and somebody used alligator clips or soldered some other type of connector onto it. I'm trying to restore them to the original configuration, so then you can use the two screw terminals and hook up your 75 to 300 ohm balun and feed in a 75 ohm signal source. Now to secure the back, since most of the screws are gone from these sets, I'm using some little sheet metal screws with washers. It's a pretty close approximation to what was on there originally. You want to use washers so you don't chew up the masonite. And I go on like so. And there we have it. I will let the owner know he can come pick up his sets.
An overhead shower. It installs in minutes. No tools needed. And no other shower head can do this. Just flip the head and AquaCare turns into a power wash. Use the fan spray to instantly rinse off
some of his wounded. He brought along his own cook. On the way over,
eating pheasant in baked Alaska while his men are in post. Always clear one's palate between courses. Yeah. Okay, no, don't do anything. Leave me alone, Father. If I think about this, I'm liable not to do it. Okay, don't.
And there we have it. I will let the owner know that his set is ready and he can come
Ruckus, and I was
pick it
forced
up.
to fight fire with fire.
Well, keep it down. I'm trying to eat in peace.
Oh, certainly, sir. Of course, I understand perfectly. Far be it from me to serve such an elegant repast. What a fool! Sorry, Colonel. Let me help clean it up for you.
Get away from me! If you weren't a priest, your life wouldn't be worth a plug nickel.
And there we have it. I will let the owner know that his set is ready to be picked up.
You more highly than anything I own. My everlasting respect. He was a sidekick?
And there we have it. I will let the owner know that his set is ready to be picked up.
Weeknights at 8, 7.
In spite of all that nicotine, cigarette, whatever tar, it actually looks pretty good. Alright, I'm calling this one done. I let the owner know he can come pick it up. Glad to get this one done. I think next up we'll be doing Tom's Princess and Debutante set. I know I said we were going to be doing triage or taking a look at some of the other sets, but this took a lot longer than I thought it would, so let's save that for the next video.
Easier than traditional stovetop cooking. No broken egg whites, no peeling, and no watching a pot boil. Now you can easily make hard-boiled eggs for a delicious egg salad, or slice them for a hearty chef salad. Prepare tasty deviled eggs with
because
ease.
cooking eggs is just so hard. You need to get a special device.
It's great when you're in a hurry.
That is
Just
ridiculous.
Pop it in the microwave and enjoy a healthy breakfast on the go. So why make eggs
All right,
the
guys.
old-fashioned way
Thanks for
when
watching.
You can quickly prepare them the new way with Egg Pod.
Egg Pod does all the...